Hello everyone, welcome back to my channel. Today we're once again diving into the exciting world of machine learning and game development. Specifically, we'll explore how to generate text and load pre-trained weights of a language model with the Llama architecture in Unreal Engine 5. Should be fun. Before we begin, it's crucial you've watched my previous video where I cover setting up the required plugins. If you haven't seen that yet, pause this video and check that one out first. While setting up the plugins, be sure to save a copy of the LibTorch distribution you downloaded. You will need it later. Also, feel free to join our Discord server for support or to join the community. Alright, let's get started. I'm using a blank C++ project without starter content today. In my previous video, if you recall, I utilized the third-person demo with starter content. I realized my error while uploading the previous project to the hub. We need to use a CMake project to convert the weights to an output archive in order to bypass occasional memory issues when loading Python weights directly inside Unreal. You will need to have CMake installed for this step. I've linked a CMake setup guide in the description. We're going to use a repository I previously created for this step, so we need to clone the repo from GitHub. First, navigate to your chosen directory and open the terminal. Next, let's clone the actual repo. This link will be in the description. Next, head over to the HuggingFace hub to get the model. I'm going to be using a model I trained from scratch for this demo. The steps to load Meta's pre-trained Llama and Llama 2 models are the same though. Save the PyTorch model file to the CMake directory. If the weights are not in PyTorch format, you'll need to save the model in the correct format. To convert the weights, first load the model from the hub locally. Then convert the model state dict to a normal Python dict and save it using torch.save. If you do not convert the weights to a Python dict before saving, you will get an error loading the weights in C++. These steps are shown in the image on screen. Next, save the tokenizers.json file to the content directory of the Tokenizers plugin. Okay, so now we need to find the main file in the CMake project. Remove all of the code that's currently in the main function. Next, we need to change the include from llama causal lm.h to llama utils.h. Start by calling the getTheBytes function, providing the path to the original weights. Next, we need to call torch_pickle_load with the return value and then convert it to a generic dictionary. Now, to perform the conversion, invoke the toOutputArchive function with this generic dictionary. Finally, save the resulting output archive to the content directory of the LibTorch plugin. I will name my model YouTube_Llama. Now, to build the project, we first need to create a build directory. Open the terminal in the root of the CMake project and run make-dir-build. Next, build the project using CMake. The commands are in the description. For the first command, we will need to determine the absolute path to our LibTorch distribution. To be clear, the distribution I'm referring to is a zip archive you downloaded from the PyTorch Get Started page. We need to use this for the CMake prefix path in the first command. After the project is built, the exe will be located in the release directory. We need to run cpp-torch.exe to convert the weights. Now, we are finished with the external setup and can start working in Unreal. Like the previous video, the first step is to create the model data asset. Right-click in the content directory, go down to Miscellaneous and select Data Asset. Select the Atum Neural Network Layers Data Asset class from the Data Asset pop-up. I'm going to name the asset Llama Layers. Next, open that asset up so we can set the model config. The config of a model hosted on the hub is located in the config.json file. I have not set up the functionality yet to read a config from file, so we have to set params manually for now. Just a reminder, you should use bfloat16 if you're using one of Meta's pre-trained models. The config on the hub is set to float16, which is incorrect. We need to add a new layer with the class Llama Unreal. As I previously mentioned, in this tutorial we're using a specific model. While you are able to use Meta's pre-trained Llama models, my machine can't handle it. The model I am using was trained from scratch for free on Kaggle. You can find the link to the notebook I used for training in the description below. In a future video, I will discuss best practices for using language models in production games. This discussion will cover strategies for integrating language models in Unreal games, why larger models might not always be the best choice, and an alternative to using large models. Next, we need to create the neural network asset. So right-click in the content browser and select Atum Neural Network from the machine learning section. I'm going to name my asset Llama NN. Open up the neural network asset and initialize the neural network. Initializing the model loads the weights into memory. The model will persist in memory through play sessions. You can initialize the model from inside blueprints if you prefer, but we are going to use the editor method in this tutorial. To initialize from editor, we need to first select the data asset we created and then click Initialize Asset Data. Now, we need to create an actor so we can interact with the model. Right-click in your content directory and select Blueprint class, then select Actor from the pop-up. I'm going to name my asset BP_SmartRock. Now open that up. I'm going to add a spear mesh so that we have something to look at. The first thing we need to do is set up the tokenizer. So let's create a function named setupTokenizer. Inside the function, we need to construct the tokenizer asset and load our tokenizer from file. The function will take the path to a tokenizer file as the parameter. The file path is relative to the tokenizer plugin's content directory. First, call the construct object from class function with the class tokenizer wrapper. Let's promote the return value to a variable. I'll name my variable tokenizer. Finally, drag off the tokenizer and call initialize tokenizer from file. Now we need to load the pre-trained model weights. The first step is to create a variable for the model. The variable will be an Atum neural network object reference. After creating the variable, we need to compile the blueprint in order to set the default value. We will set the default value to the neural network asset we just created, named Llama NN. We are going to create a second function named setupModel. Similar to the previous function, we need to create a parameter for the path to a model weight file. We will name this parameter modelPath. Inside the function, drag off the model variable and find registered layers. Get the value at index 0 of the layers array and cast to Llama Unreal. Promote this to a variable named asLlamaUnreal. Drag off the Llama Unreal variable and call the loadParams function. Next, connect modelPath to the loadParams function. The file path is relative to the LibTorch plugin's content directory. The path to our model would be youtube_llama.pt. Finally, let's pass on the bool from loadParams. Next, we need to encode the text and set the tensor values. Let's create a function named Encode as Tensor. The function will take in a string and return an encoded tensor. Drag off the tokenizer variable and call the encode function. Promote the return value to a local variable named input IDs. Next, we need to convert the input IDs to a tensor. To do so, we need to create an empty tensor using the empty tensor function. Drag off the shape array and utilize makeArray. This array represents the shape of our tensor. We are only using one input sequence right now, so our batch size would be 1. We need to add a batch dimension to our shape as Llama expects a 2D tensor. Set the value to 1 and add a new pin to the makeArray node. To determine the sequence length, we need to get the length of the values variable. Next, connect the length to the second pin. Promote the shape to a local variable named inputShape. Let's promote that empty tensor to a local variable named inputIDsTensor. Now, let's assign the values of our inputIDs variable to the newly created inputIDsTensor. To set the values of our tensor, we need to call the aptly named setValues function with our tensor. We need to pass this function our inputIDs variable and our shape array. With that step done, we have the ability to load pre-trained weights and encode strings as tensors. Now we can utilize the model to generate new tokens. Currently, I'm streamlining and simplifying the multi-step procedures involved in using these libraries. My goal is to make it easier for you all to use them in the future. With that in mind, let's create a new function named Generate and Decode. This function will take two parameters. The first will be an integer named num_new_tokens. The second will be a tensor named input_IDs tensor. Drag off the Llama Unreal variable and call the generate method. Connect our input_IDs tensor to the input parameter. Then, connect our num_new_tokens variable to the num_new_tokens parameter. Finally, we need to deserialize and decode the output. Let's create a new function named Deserialize and Decode. The input to this function will be a tensor named model_outputs. First, we need to call the getSerializedValues function on the output tensor. Now, let's deserialize the out values using the deserialize function. In order to specify the type of the output array, we need to create an array with our desired type. We want an array of integers. To create the array, we need to use the makeLiteralInt and makeArray functions. To convert the deserialized tokens to text, we need to call the decode method on our tokenizer. After passing our deserialized tokens to the decode function, we will have our output as a string. We are now finished with Deserialize and Decode. Now it's time to bring it all together. So, to start, let's go back to Generate and Decode and connect our newly created function. Finally, we'll create a function named GenerateWithString. This function accepts an input string and the specified number of tokens to generate as its parameters. It will return the generated output from the model as a string. Inside the function, we first need to call Encode as tensor with our input string. Then, we call Generate and Decode with the resulting input_IDs tensor. The last thing we need to do is return the generated string. Let's test this out to confirm that everything is working correctly. So let's head over to our event graph. We need to start by setting up our tokenizer and model. If you're not already aware, we do not need to call the setup functions every time we want to generate text using GenerateWithString. As I previously mentioned, the path to our model is youtube_llama.pt. Let's branch off the return value. If it is true, let's print model is loaded. Let's repeat the same process with our tokenizer. The path to our tokenizer is tokenizer.json. Next, we need to call GenerateWithString. I am going to use once upon a time for my prompt. The model we are using in this video was trained very quickly and it can barely speak English. Also, I didn't bother to tune the hyperparameters. If you are interested in a more capable model, there's an article on my Discord covering a strategy for training models to act as NPCs. Let's print the generated output. Okay, and the moment of truth.